Okay, I guess I'm just gonna start recording. So yeah, this is TIC80, the code editor that is. And I'm working on a little game for Low Res Jam. The Jam is a 2-week event where the goal is to make a game with a 64 by 64 resolution. So that's really small. I'll show you what I've got so far. So this is like, you have this board right here, which is, of course, it's scaled up, so it's not exactly 64 by 64, but it's a multiple of that. And you can start by choosing one of these shapes right here at the bottom. I like the big shape, so I'll take that. And then you can place it on the board somewhere. Let's put it here. That's actually my usual test location here, because it contains a bunch of objects of interest. So you start, when you place the shape, you start excavating the kind of like mine or whatever dungeon this could be, a cave maybe. It's a bit inspired by the Pokemon Sinnoh games. They have this fossil mini game. It's kind of like inspiration for this. But yeah, you get a value booster, and this increases the value you get per tile. And once the shape is fully excavated, it will show you how much value you got. And it's not implemented yet, but since this is only day 2 of working on the game, but the value can be used to like attack an enemy or heal yourself, or maybe like use an ability or something, but I haven't designed the game so far yet. I'm just working on the basics. And then you keep excavating, and now you found a new shape. So this goes into your inventory and it shows up here, but you cannot make selections here. Just shows the inventory. Now you can see that you gained 23 value here. So you got, is that right actually? I think that's right. Yeah, that's right. Yeah, because you got the 1 as the, I think the 4th tile is the value booster, so by default you get 1 point of value per tile excavated, but the value booster increases that value by 1. The value addition. And then it just begins a new turn. And you have the shape that you discovered. So you can use that one here. And everything except for the first shape, which is the 1 tile, the single tile, will get cleared from your inventory. But you can use single tiles as many times as you like. It will never get removed. So we found nothing there. Okay, let's try it again. This is kind of addictive, not gonna lie. Value booster. Okay, so that's a 2. So we now have value per tile is 4. So it was 2 for the first tile, but it is 4 for all the tiles, including this one that we just excavated. So we should get 14 for this. Yeah, it's 14. That's correct. Okay. So there's not much more to this game yet. This is just a very basic kind of simulation kind of thingy. This is how my games usually start out. I kind of don't design everything at once when I start the game. I just kind of let the process lead me towards some kind of destination. But I'm recording this video because I want to show you how this game is made, because I think that's really cool. So we're back to the code editor here. This is Lua code, and we're using TIC80's functions. So we have a function TIC, which is a make function. You can also make the TIC a variable. I usually do this for implementing like title screens or other states of gameplay. Okay, but the main function is just, okay, we're clearing out the screen, and because it's Low Res Jam, we are clipping the viewport, so we cannot draw beyond 64 by 64 pixels. Then we draw the border and the decorations, and here's just, it's a bit messy I think, but it's just drawing the map, the actual game area. Then this is the animate function. This is a heavy heavy hitter because it runs the entire game logic, this one function. Of course it runs several sub-functions and so on, but just by calling this function the game will run. What happens if we don't call it? Okay, so then nothing happens, it's just an empty screen. There's no events happening, there's no game logic at all, this is just an empty game. How amusing. Let's bring it back here. I do realize the animation stack system is like shortened to ASS, so I gotta think of a different name for it. It's not an animation system anymore. I originally thought of just making the animations with the system, but then I realized I can make all the game logic, all the events, like the text boxes coming up, the inventory coming up, the inventory items being selected, all that can be like a like functions in a, I'll show you later. It's a stack-based system anyway, that's all you gotta know for now. This is just, what is this? Oh yeah, this is just coloring the, I should comment here. I'm gonna edit the code as I go, because it's nice to clean up the code now that it's kind of in a stable state. So this is just coloring the background. So if we comment this out, we can see that this is just yellow, but here we get the stripes. The stripes are not aligned to the grid because the grid is 5 by 5 tiles and there's 12 of them, so 60 pixels total and 4 pixels for the border. But yeah, the stripes are like 4 by 4 tiles, so that's kind of might be a little bit concerning. I don't know, it's not concerning, it just looks a bit weird if you have a excavated cave and then you start examining the pixels. But I don't think players actually pay that much attention. Oh yeah, I usually do in my games. Then we remove the clipping and we scale the whole viewport, clearing the original image in the process, and then the time keeps advancing by 1. Okay, so here we arrive to the animation stack system, and this is gonna take a long time to explain probably. So this is the actual stack of animations or events in general. And we can add something, so this takes a function f and info, which is like an parameters for that function. So here's just the regular table insert function in Lua. This will insert into the A stack whatever is returned by the function f. And to make sense of that, we might have to look at some examples. Yeah, this isn't, I cannot explain this linearly, we have to kind of bounce around. We can use the outline to do so. So let's like start with, actually want to start with the reset turn function. So the reset turn function is just clearing out the stack and adding a bunch of basic events. So a message box saying new turn. I think this is readable, even if you don't really understand what each part of this line does, it will still make sense because it's almost like English. So just create a message box event and then the message box has a saying new turn. That's simple enough. Then the inventory comes in and these are played in sequence. So when the message box is done, whatever the meaning of done is, in this case it's when we press Z. So when we press Z we move to the inventory step and then the cursor step, which is the placing of the shape, and finally there's the reset turn event again. So this is like adding itself to the stack, and this is kind of like confusing. You have to counter because when we go to the animate there's a lot of code here. So this is the animate function. This is what we called in the main function, and it's not that long. So you take the currently running animation, and there's a failsafe here if it's nil. If you're reading beyond the tables limits, then we just return. But we play the animation. Yeah, these are still called animations. It's kind of a legacy thing from the first day. Some more like events. But anyway, we play the event, and then if this returns true, if the event returns true at the end, the function of the event, then we will increase the stack index. So we will start playing the next animation. So you can see that these animations or events are running in sequence, and you can only have one playing at a time. So that's kind of a limitation, or maybe a possibility of the engine. I kind of like it, having this whole language of it's just sequential events. That seems pretty elegant to me, but I might want to expand it with like arrays of currently playing animations. It would be possible to do so. Just gets a little bit messy. So because the reset turn function immediately returns true, then this immediately increases the stack index, and we end up past the first event that we were trying to access. Where's the reset turn again? Here's the reset turn. So okay, so we just need to counter that. Never mind that. That's kind of not so beautiful code, but anyway, we start from the first event, which is the message box. Then we move to the inventory event, and when we select an item, we move to the cursor event, and then there is the reset turn event coming up after the shape placement. So what is going on here? How does the game play at all? How do we play the game? So what happens here is that the step cursor is actually spawning more events into the stack, as it's a dynamic stack, so the stack is expanding as we are executing it. And that's really easy to do in Lua. I think in C you would have to do some manual memory management, and it would take a lot more code, but in Lua it's very simple. Tables are dynamic by default. Tables are the only data structure in Lua. You can basically do anything with tables. These quickly boys. It's an array, but it's also a hash map. So if you want an array, you make a table. If you want a hash map, you make a table. If you want something like a tree structure, you make a bunch of tables containing tables. You can basically represent every data structure that way. So yeah, step cursor. Let's take a look at that function, because that's kind of complicated. That's where the meat of the gameplay is happening here. And this also is the first time we see the syntax, or take a careful look at the syntax of the events. So what is this function returning? It's returning a bunch of stuff. But it's basically returning a table. You can see here. It starts a table, it contains a bunch of stuff, then it ends up here. The function ends there. So we have in this table an init function right here. And it just gets a bunch of like non-global data passed into it automatically by the anim add functions and all of those stack management functions basically, which are defined above. But this is the place where the game logic functions are defined. So the init function is simply setting the cursor position, and then we get the shape of the currently selected inventory item. So you can see inventory is a global variable. I decided to make it so because it doesn't hurt anyone. The inventory is changed in the first event, or the second event, because the first event is the message box saying new turn, and the second event is the inventory selection. So this that function sets, or that event sets the cell variable, and we just get the shape that matches that. So basically just a number, an ID number. I'll show you the map here. Oh, this is kind of messy. So I have here the map, which is just a 12 by 12 grid of yellow blocks. And then the items contained. So this is the spoiler for the game. These aren't randomly generated yet. That would take like... I do have a Perlin noise implementation from a couple of previous games, so I can probably use that to place some items there. Never mind that. Here are the shapes that we have. So these are basically... Here's a 5 by 5 block. So this is the first shape, which is just a single tile, which never runs out. It's infinite. But this is the second shape. It's also 5 by 5. It's the big shape that we tried out when I was showing you the game. And so this is shape 0, shape 1, shape 2, shape 3 and shape 4, and there are no more shapes currently defined. But you can see here, because TIG80 offers this map, you can use it to your advantage. Basically you have all this space to work with. And you can just store information in the map and parse it as you play the game. So that's really convenient. You don't have to invent a sense of space like you would in, say, Love, which is another Lua-based framework for making games. So in Love you would have to like have tables containing a bunch of position strings, and it's a lot less visual than this TIG80 thing, where you can just put a bunch of tiles on a map and that's it. Yeah, these shapes are parsed by the getShape function here. And this returns the shape. And this is where the init function actually returns something. So this is what is set into the local data of the stack, the A stack table. So that we don't have to make everything a global variable. That would get messy real quickly. It's okay in a game to make the inventory a global variable. I don't mind that at all. Sometimes people are really scared of global variables. I wonder who teaches them to be like that. So this is the play function, and this is the play function is called once per frame. Init is just called when the event is started. And yeah, this is just game logic. This is like how you make a cursor that moves. And I've written this kind of code like a zillion times. This is how you visualize it. It's a bunch of blinking rectangles. And then we do the check for Z press, button press 4, and TIG80. It starts carving the shape, and here it starts doing these interrupts, anim interrupt. I'll first explain this one, because these interrupts are in the wrong order. The first interrupt is actually the last coming in the sequence after this. So it's kind of like, it's not too confusing, but it's just something to keep in mind when you are visualizing the stack and how it works. So we are interrupting the stack after the step cursor event to place these step shape piece events, a bunch of them, one for each tile in the shape. And each of these interrupts will create an event that is an animation for each of the pieces. And this is the message box that comes afterwards. It will tell you how much value you gained for all the pieces. This isn't all the interrupts that are going on, because the step shape piece event does create even more interrupts. Like when you discover something, when one of these animations, let's first look at this actual function here. So this has an init function also, but we look at the play function. This plays an animation, and the animation ends, then we can find something. If we find something on the map, then we do another interrupt, and this creates a step discover event with some arguments here. These are just map positions in this place. So where we discovered something, it's just two numbers. So we take a look at the step discover function, and this is a little bit more complex. I'm not sure if this is good design, if this is really like how I should be doing this event system, because this is a play function and it's supposed to run once per frame, but this is immediately returning true. And if you remember from the animate function, when we return true, the stack advances, the stack index advances, and we move to the next event. So it's just running once and then immediately moving to the second event coming after this. But we need this kind of like intermediate event to create a bunch of interrupts based on game logic. So if the item is a shape, then we give a message saying found a new shape, and we add it to the inventory. Step inventory tree, what is this? Oh yeah, the inventory tree is like, it just flashes the inventory. It doesn't let you interact, it just shows you. It should be something, be called something useful. Sorry, I'll finish this train of thought first. Yeah, so if we have a, let's take a look at this variables here. So 21, so the ID is about 21. You can find a single tile, I guess. There's no reason why you would find a single tile, because you have infinite of them. But you can find all these tiles, all these 4 tiles in the map. And if that happens, if you step on one of these tiles while excavating the shape, then we add it to the inventory, and we communicate the info coming into this function, which contains just the X and Y positions on the map of where we found something, and then the inventory add function does things with the position. And then finally we flash the inventory just for convenience. But if it's less than 15, what's in the map? So it's like one of these. I kind of reserve these tiles also. They might contain something like power-ups or something. You gotta think ahead when you're making a game. Because right now there's only these 3. These are the value boosters, I think they're called in the game. But these graphics aren't actually used because these are 8x8 sprites and we use 5x5, so I'm just printing text with the smallest font available in TKD for the actual graphics of the value boosters. So we do another event, and remember these are in reverse order, so value add happens first, then this, and then finally this. So we add the value, just communicating to global variables again. Then this message box saying value booster. And there's this limit argument also. It's kind of just like a I'm just telling the message box where the highlighted tile is, and if this message box overlaps the highlighted tile, then we will adjust the position of the message box. That's the simplest way of putting it. And then there's another message box interrupting you to tell the value per tile currently. There's a lot of message boxes in this game. I think these should be like, I should start like considering how to display multiple message boxes at the same time, because when they are coming in sequence, it's kind of making the game like less enjoyable because there's pauses after every action. But I do like the pauses. I do like that there's like it's the same reason why I like Pokemon trading card game for the Game Boy Color. It's got this event-based design where you get like one message at a time and it waits for your input to move to the next message. That's what inspired me to make this stack-based system here. And this solves a lot of problems, I will admit. It does make the game logic more elegant than, like, imagine if I was trying to make this structure with just a flat main function. I would need like variables to keep track of state, and then I would need like if this state is this, and then we will play the message box animation. It just gets messy really quickly. This is like a more modular way of doing it, I think. No, I'm sure. I don't just think, I'm sure. I know from experience. And finally, whatever here happens, whichever discovery we have made, then we will remove it from the board at the end. Again, this is the last interrupt that we'll play, even though it's the first that we return here. So yeah, to recap, we start in step reset turn event. This is just where it's first added at the start of the game, while this code is being run from top to bottom. Like this is all running here. These functions are getting defined, and then it runs this, and that kickstarts the game, basically all the game logic. But the step cursor is an event that spawns more events that spawn even more events. I like that. I kind of like that hierarchy. I don't mind it at all. It's just a modular way of designing game logic, because you have to represent this anyway somehow. And this is just one way of doing it, with events that are sequential. I like this system. I think it's kind of elegant, and it's certainly easily expandable, because I don't currently know all the details of the game design. So whatever I decide, I can implement pretty straightforwardly with more events that spawn more events and so on. Like when I want to create an enemy turn or something, then I can just aim at step enemy turn and it's done. Bam. Obviously you have to write the function, but I can focus on one kind of like level of hierarchy at a time. You get what I mean? This is the overall game flow, not the flow. Game loop is the word I'm looking for, or term. The game loop is here. This is the game loop. Actually, the message box isn't really part of the game loop. It's actually this. Inventory, cursor, and then start again. So I like that this is laid out here like this. And let's take a look at a couple of events here. Oh yeah, I forgot, some of these were kind of badly named, like inventory tree or something. I gotta rename this. Like step inventory tree. I don't want that to repeat in my code. I want it to be like step inventory flash. Done. And then go to step inventory tree and change the name. And we also look for remnants of this. It's not mentioned anywhere in the code, so we are done. Step inventory flash. Okay. And this, as it says, just displays the inventory after it changes. So it does this interpolation thing of moving the inventory Y position with a fraction of the difference to its end position. It's just a basic interpolation method, very common in game development. And you draw the inventory. This is just a function. We don't really need to care about what's inside that. But we do care that we don't pass anything to it. Nothing is coming in as an argument, because the inventory is a global variable, and we know its state all the time, so it makes sense to have it be a global variable. I will die on that hill. I'm not going to pass the inventory to every single function I use ever, because that would be really stupid. That's not how I design games. I don't want to write the inventory everywhere where I use it. I know the inventory exists. It's a global variable, and that's it. So here, this interrupts. This is also like it automatically creates the inventory 2, which is also badly named to be inventory fade out. Now we need to change the name here, inventory 2. So it's inventory fade out. I think this is used in a couple of places, so we'll change the names everywhere. Here, fade out. It's a bit cumbersome, I will admit, but you don't. I don't need a replace function here because I don't have that much code. It just, as you can see here, is 343 lines, and I have. If I mention some name of a function, I probably do it like twice or 3 times at most. But yeah, TIG80 could use a replace function. It doesn't have it. I'm not crazy, am I? It doesn't have a replace function. Just has the find, bookmarks, outline. The outline is the most useful because you can see every function. So this is the entire game. This is what the entire game basically is contained within. So far. It will get larger, obviously, because this is not a finished game yet. Nobody would say this. It is a playable game. I could release it as well if I wanted some feedback, but it's simple enough that I can playtest it on my own, so I don't really need outside playtesters right now. They'll just say that it's kind of cool and it plays well, and they don't have anything to say about it because it doesn't offer any kind of challenge yet. There's nothing you do with the value you get, so that's the biggest obstacle to having a fully finished game. When the value is meaningful, then I can start looking for playtesters. I've been streaming for half an hour now. Is that enough code content? Oh yeah, I should totally call this series like code content. Let's make it so. Yeah, I could look at other games in the series, like other TIG80 games I've made and other Love games I've made. And I also made Love DOS games and Castle games, and they're all Lua-based frameworks. But TIG80 is very suitable for low-res champ because you have direct pixel access. In Love you don't really have the concept of a pixel, or you kind of do, but it's abstracted away, so you need to jump through hoops to get access to what the value of a pixel at the screen is. Because everything's just canvases, and canvases are run on the GPU. And no, TIG80 is running entirely on the CPU. It doesn't use the GPU at all. For better and for worse. Try making a 3D game in TIG80. Yeah, right. I have made a 3D engine in TIG80 and it ran like a slideshow. It was just embarrassing. Then I made ported that engine to Love because it was kind of easy to do because both are Lua based. So there I got GPU access and bam. Obviously it wasn't so simple because I had to convert everything to like shader logic, and it took a lot of learning to do so, and a lot of asking for help in the Love Discord, which was very helpful for me. But now I have a 3D engine in Love, and I'm kind of making a big game for it. But I need to make some smaller games first, I decided. I'm not in a hurry to finish my mega project just yet. Yeah, every simple game I make is kind of a stepping stone towards a bigger goal as a game developer. But every project also deserves to exist on its own. It's not just a stepping stone. The box function is kind of ugly, and here I also found that some of these coordinates are they're offset by 1 somewhere. I think I could file bug reports since TIG80 is open source. Like the line endpoints are offset by 1, and that's just kind of silly to me. Get shape. It gets the shape. What can I say about it? That's the reset function. The source of everything, inventory flash, inventory fadeout. Yeah, these are better names. Let's also test the game. I changed a bunch of stuff, so does it still run? It seems to. 1, 2, 3, 1, 2. Value booster. Libertalis 2. Yeah, this is too many text boxes. This is like getting a bit annoying. And another text box. Yeah, this is too many text boxes. Yeah, I gotta do something about this. But yeah, that's a simple game I'm making, and the code is kind of elegant, I think, because it's so modular and easily expandable. Yeah, that's it for this episode of Cozy Code Content, my new series, which I just decided I will start. See you next time.